Well, now we come to the concept of pulley. So pulley is basically fixed at one point, that is a single pulley, and a string is allowed to pass over the pulley. There will be two free ends. At the two ends, we suspend the masses. So one of the masses is M1, the other mass is supposed to be M2, and we make assumption either M1 is greater than M2 or M2 is greater than M1. Let us assume that M1 is greater than M2. Now, if we assume that M1 is greater than M2, it means that the mass M1 with weight M1G will start coming down and M2G will start coming up, going up. Their acceleration remains the same because the string is not changing. Both are the parts of the same string. So against M1G, the tension is T, and against M2G, again the tension is T. So to the one segment, we will say that M1G minus T will be equal to M1A, and for the other part of the string, we will say that it is T minus M2G equals to M2A. Now, forming these two equations, the tension will cancel off and we get the value of acceleration. Then out of the two equations, we put the value of A and we get the value of tension. It is found that the tension on the string is found to be 2 M1 M2 divided by M1 plus M2 into G. Whereas total tension on the pulley, that is 2T, because T is upward and the pulley is being pulled downward. So 2T means 2 multiply whatever is the value of tension you have estimated, that is 2 M1 M2 divided by M1 plus M2 into G. So in all, the numerator will become 4 M1 M2 divided by M1 plus M2 multiplied by G. Now these facts are to be indicated. So a single fixed pulley changes the direction of force only and in general assumed to be massless and frictionless. Now we will take an example. A bucket of mass 25 kilograms is raised by 50 kilogram man in the two different ways as shown in the figure. What is the action on the floor by the man in two cases? If the floor yields to a normal force of 700 Newton, which mode should the man adopt to lift the bucket without the floor yielding? So we will say that mass of the bucket is given, mass of the man on the platform is also given. Man is on the platform, so weight of the man will act vertically down, and small m, mass of the bucket is 25 kg. Force applied to lift the bucket is F is equal to mg. M is known, so the number will become 245 newtons. Weight of the man will be mg is equal to 50 into 9.8, it is 490 newtons. That is double of the initial value. Now we have to go through with figure A and figure B. So in figure A, when the bucket is raised by the man by applying force F in upward direction, the reaction equal and opposite to F will act on the floor in addition to the weight of the man. Now we are finding in figure A, the person is pulling the rope upward, the bucket is going up, weight of the man is mg downward, so force applied is F. So weight of the bucket mg will work downward. And in figure B, like now you are seeing that pulley is moving when the string is being pulled by the man. So force acting on the string is downward, weight of the person is also downward, but the force acting on the bucket is upward and the weight of the bucket is downward. This is what indicated in the two figures. We have to go through with the reaction on the floor where the man is standing. Therefore, action on the floor is mg minus F, 490 minus 245. It will be 245 newtons. And in the mode B, should be adopted by the man to lift the bucket. Now, motion of the body is connected by string and pulley. Case 1. Now, here the pulley is indicated. And on the right side of the string, we are finding that T are equal and opposite in B and A. B and A are the two loads and their weights are acting vertically down. And the remaining two figures are the free body diagrams of A and B. So when tension is upward, the weight mg is downward. And if acceleration is zero, that tends to that velocity is constant. Now we have to go through with case 1. M1 equal to M2 is equal to M. The tension in the string T is equal to mg, acceleration A is 0, and reaction at the pulley is 2T. When we will calculate this reaction, it will become 4m1 m2g over m1 plus m2. So 2T is equal to 2 mg. So mg is downward, both forces are downward, so it is 2 mg, and 2T, that is upward, 2T is equal to 2 mg. 2 will cancel off and T will be equal to mg. Case 2, m1 is greater than m2, for mass is m1, m1g minus t is equal to m1a, and for mass m2, t minus m2g is equal to m2a. This I have already discussed. So here it is shown in the form of equations. There are two equations. If we add the two equations, t will cancel off, and from the remaining portion we get the value of a. So it is shown in the figure. That is, again, the same block diagram is indicated, and we get the value of acceleration. The acceleration on solving is found to be m1 minus m2 over m1 plus m2 multiplied by g. And similarly, the tension. To find tension, we have to consider any one of the equation of tension, and we compute the value of A to get the value of tension. And that will become 2m1 m2 into g over m1 plus m2. And the reaction at the pulley will be 2T, or the tension on the pulley will be 2T, and 2, it is written as it is, and for tension, we compute the value. The net value will become 4m1 m2 g over m1 plus m2. Now we come towards case 3. In the figure, we can take help of the figure. Now for force acting on the system are shown in the figure. I have already described the figure. Now we are writing the equations. For mass m1, T1 minus m1g is equal to m1a. Then for mass m2, according to the figure, m2g plus T2 minus T1, that is equal to m2a. And for the third mass, that is m3g minus T2, will be m3a. These three equations are formed, and from here we have to estimate the value of tension and acceleration. So if we solve these equations by substitution and elimination, we get the value of A. So the value of A comes to be m2 plus m3 minus m1 divided by sum of the masses, m1 plus m2 plus m3 multiplied by g. Putting these values in of A in equation 1 and 3, and then we can estimate the values of T1 and T2. Now we come towards case 4 for mass M1. Now it is in the figure. A table is indicated assuming the surface frictionless and pulley massless. Tension for M1 is indicated, and when the string is horizontal to table, acceleration is indicated. Now on the other side, the string is passing over the pulley. Tension on the string will be upward, and the mass of the block is m2, so weight is m2g. m2g is operating vertically down, and the acceleration with which the mass is moving down is taken as a. Now in this case, mass m1, that is t, is equal to m1a. For m2, it is m2g minus t is equal to m2a. And if we solve them, then we get the value of acceleration. And the value of acceleration is computed in equation number 1, that is t is equal to m1a, and the final value of t comes, that is m1 m2g over m1 plus m2.